All right, so coming back for the evaluating composition of functions. All right, so composition of functions is similar to something we just did, but it's a little weird, okay? I find it weird, you're going to find it weird. Maybe, maybe not. Anyways, a composition of a function g with a function f, you are basically finding f of x first and then plugging what f of x is into g of x. So it's kind of strange. So like, for example, the input of f is x, then the output would be f of x. You would input that into g and get this. So the domain of H is the set of all x values such that x is the domain of f and f of x is the domain of g. So we'll talk about domain and range again some more. Let's dive right into this. All right, so we are evaluating using the function f of x is 2x plus 1, and then g of x is x squared minus 4. So we're going to use that to complete this table. Okay, so they give us a value of x that they want us to use into f of x. So we're going to take this value, we're going to plug it in to this one. So we're going to find f of 0, and we're plugging that into 2 times 0 plus 1. All right, so 2 times 0 is 0, 0 plus 1 is 1. So we have the square root of 1. We can solve that. That equals 1. Okay, so here's the weird part that seems a little strange. So we're not going to take 0. We're going to take this value that f of x equaled, and that's getting plugged into g of x. So that is what g of f of x means. So basically you're taking this and plugging it in to that. Okay, so we have technically g of f of 0 is equal to g of 1. So we're finding the value of g of 1. So we're substituting that into g of x. So now we have 1 squared minus 4, which equals 1 minus 4, which equals negative 3. Okay, so when x is 0, g of f of x is negative 3. If you would like, you could try some of these and pause the video and then fast forward to the part where it's worked out and see if you got the right thing. All right, so actually, you know what? I'm going to pause the video and I'm going to set up all of these for the f of x just to save video time. So you don't have to watch me write. So you should do the same. All right, so if you did one step further, that's fine. So we're looking at this, 2 times 1 is 2, 2 plus 1 is 3. So we got the square root of 3. We cannot find the square root of 3, so it's that. So when we do this one, it's going to be with square root of 3. All right, so we have g of, you know what, I'm just going to go down here, and then that way I can pause this for a little bit too. Okay, so then we have 2 times 2 is 4, 4 plus 1 is 5. So we get the square root of 5, can't do anything with that. 2 times 3 is 6, 6 plus 1 is 7, so we get the square root of 7, also a prime number, can't do anything. 2 times 4 is 8, 8 plus 1 is 9, and we can find the square root of 9, it is 3. So now, over here for our g, we're going to plug in the answers. So if you want to pause and set that up like we did this one, that's what I'm going to do. Okay, so hopefully you saw my mistake I made right here where I put f instead of g. I don't know why. All right, so remember, when you square a square root, they undo each other. So this becomes 3 minus 4, which equals negative 1, because this would be a 3 if you undo those two parts. Same thing here. Square root squaring undoes each other, so this becomes 5 minus 4, which equals 1. 7, same thing, 7 minus 4, which equals 3. Now this one is not a square root, so we're actually going to square 3. So 3 squared gives us 9. 9 minus 4 is 5. All right, so a little strange, just feels a little weird at first, but it's not too bad. So now we did this one. Example 2 is similar, but they've got us doing it different ways. And in this situation, they did not give us a value. All right, so Like this one, they told us for x to use these values. So this one is a little different because they didn't tell us to use those values. So what we're going to do with this is the same idea though. So I have f of g of x. So basically what I'm going to do is I'm going to take f of x, but where I would normally plug in a number, I'm going to plug in g of x. All right, so let's get started. I'm going to put a line down here and do a off to the side. So we are doing f of g of x. So basically what we're doing is we're saying f of g of x. Well, what is g of x? The square root of x minus 3. So that's what we're plugging in when we see the x in f of x. All right, so we have 2, but instead of x, we're plugging in square root of x minus 3. Because if that was 5, you would plug in a 5 there. Same concept. All right, and then we have a plus 5. So don't forget that. Biggest mistake is leaving things behind. All right, so we can multiply this. We're just simply going to rewrite it as 2 times x, the square root of x minus 3 plus 5. Nothing we can do with it. This is where, so the domain and range for this is where your transformations of functions come into play. You can, one, you can graph this. Or 2, if you know your transformations and how they affect your domain and range, you can use this. So what I'm talking about, we have a radical function. So we know that a radical function's graph looks like something along those lines, right? So my domain is not all real numbers because this does not go to infinity this way. If I take what I've learned in this chapter, having this means that I go to the right 3 times. So that means if I was to graph this, it would move to the right 3 times and it would go up 5 times, my bad. So our domain is affected by the left and right movement. Your range is affected by the up and down movement. So because of that, your domain would be all values that are equal to or greater than 3 because you started at 0, you moved it to 3. You started at 0, you moved up to 5. So your range is all values that are greater than or equal to 5. All right, so hopefully, if not, like I said, all else fails, you graph it, get the information from there. All right, so let's move on to b of x. I don't know how much room I'm going to need. All right, so b of x, oh my dear Jesus, g of f of x. So this time we're taking g, and for g, we're going to plug in f of x. So where the x is in g, we're plugging in what f of x is. So we have the square root, but instead of x, maybe I should do it in a different color just to show it. So instead of x, we have 2x plus 5, and then you still have that minus 3. So we'll draw a line here for b, and we'll just move c that way. All right, so we can combine our like terms. So this does become the square root of 2x plus 2. So now we can also look at this and determine our domain and range. If you want to pause it and guess your domain and range and come back and see if you're right, that would be a great thing to try. All right, so let's talk about our transformation. How would this move? This would move to the left 2 times. Would it go up or down? It would not. So moving to the left 2 times means that our domain is all values greater than or equal to -2. So keep in mind though, these are both positive. So if we had a negative, it would be going down, but your domain would still be the same, your range would be changed. So in this case, our range does not move, so it starts off at 0, so this stays y is greater than or equal to 0. Okay, so I forgot that there was a horizontal shrink, which moves it closer to your y-axis. So a little different. This is where graphing may come into play. So if you set this equal to 0, what would your value of x have to be? Well, this together would have to be -1. So what I'm saying is I'm setting 2x plus 2 equal to 0 in solving, so I would subtract 2, then divide by 2. So that would give me x equals -1. That is our domain. I apologize. I wasn't thinking about the horizontal shrink. That's right there. All right, range is still good. Okay, last one, f of x. So we're basically taking f of x, but we're going to plug in f of x into f of x. I know. Why? Because they said so. All right, so f of x, well, that means that we're going to plug in 2x plus 5 into the x spot. So we got our 2, and then in the x spot is going to x plus 5. And then we have plus 5. All right, sound fun? Right. Okay, so now we just have to combine our like terms. This one shouldn't be too bad. First, you're going to distribute. So 2 times 2x gives you 4x. 2 times 5 gives you 10. Then we have a plus 5. So we're going to combine our 10 with our 5. We get 4x plus 15. All right, so this is a linear function. So with a linear function, your domain and your range are all real numbers every single time. All right, all real numbers, domain and range every single time. All right, so I want you guys to try this because it is a little weird. You must pay attention to detail in order to not mess this up. All right, so they're throwing a curveball in and giving you an h of x. At least at the minimum, try 5, 6, and 7 because 8 is similar to 7. So they're giving you f of x is 2x squared, g of x is 4x minus 3, h of x is 5/10 x plus 2. So you're going to also state the domain and range. So give those a try as well. So please pause your video now, give those a try, come back when you're finished. I know you're waiting on me, so pause your video now. So I just wanted to give you one, just in case you wanted to see if you're on the right track. F of g of x, so f of x was 2x squared, so plugged in g of x in for that. May need to do box method unless you want to do the formula that you've learned. You get this multiplied out. So this is your answer. This is a quadratic formula, right? Because it's squared. So your graph is going to look like this. So your range is y is greater than or equal to 0. Again, if you are unsure, put this in Desmos. Put this in a graphing calculator. Look at the domain and range. All right, remember, domain is how does your graph go this way? Range is how does your graph go this way? Okay, so if you didn't already, please pause again and try number 6 and 7. I will put 8 up if you want to give that one a try as well. F of x, you're just plugging that in for x, so really you just have to multiply the 4 times the 2, you get this. Now, it is a square, so that means it's a parabola. This means it translated down 3 units, so that's where the vertex is because there's no b value, so the y-intercept and the vertex are the same. So your range is y is greater than or equal to -3. Again, if you're unsure, graph it and look at the graph. All right, f of x, this one was fun. So you had to distribute the square to both, so 2 squared is 4, x squared raised to that square is times, so you get x to the 4th. You get 8x to the 4th. This is an even function, so it would look like either a parabola or a W. So your domain is all real numbers. Your range, because there's no translation up or down, would be y is greater than or equal to 0. All right, last one. Sorry, I made a boo-boo, and my red pen you can't erase. So I just started over. I forgot to write this. All right, so we're plugging in x. We're plugging in what h of x was, and then you're just distributing. So that's where this came in. We add the 2. This is a linear function because there's no exponent. It's 1. So it's a linear function. Linear functions, domain and range is always all real numbers. So hopefully you found that not too bad. Like I said, it's more stranger than anything else. All right, last question. Modeling real life. They like to throw in word problems, so if you see something like this, you need to know how to do it because it's not that challenging. It's kind of what we were just doing. All right, so the function c of m is equal to 15 minus 10.5 m. It approximates the temperatures in degrees Celsius at the altitude of m miles. The diagram shows the altitude in miles of an airplane t minutes after taking off, where t is the set of values over the interval 0, 30. So remember that's like 0 to 30. Find c of m of t and evaluate c of m of 30 and explain what it represents. So here's our other equation right here. All right, so our first instruction is to find c of m of t. So that's our first instruction. So how are we going to do that? Well, what is m of t? Well, m of t is 0.2 t. So we're going to take this just like we did in the other ones, and we're going to go substitute it into that equation. Okay, so this becomes 15 minus 10.5 m, but instead of m, we're writing 0.2 t. All right, so then we got 15. We're going to multiply that together. That gives us a 2.1 t, and that's what we got for that. Okay, so now it says evaluate c of m, oh my goodness, c of m of 30. So we're going to take this just like we did the other one. We're going to plug in 30. Oh my goodness. C of m of, oh dear Jesus. Good thing this last question, because I don't know if I would make it. All right, so remember, we're plugging in 30 for t, okay? So we have 15 minus 2.1, but instead of t, we're plugging in 30. And we're going to simplify. So then if you put in the calculator 2.1 times 30, you will get 63. 15 minus 63 is negative 48. Okay, but as always, if you have a word problem, you have to answer your question in words. You cannot just leave it like that. Plus, it said explain what it represents. So that's part of your instructions. All right, so what does this represent? So you get negative 48. We plugged in 30, which was given here. And remember they said t, which is the time, is the set of values over this interval. So they're saying that negative 48 indicates that after 30 minutes, the airplane is at an altitude that has a temperature of negative 48 degrees Celsius. So this altitude that the plane would be at is negative 48 degrees Celsius. So I will write that down, but I'll pause it to write it, not make you watch me write it. All right, so does that all fit? Yes. So c of m of 30 that equals negative 48 indicates that after 30 minutes, the airplane is at an altitude that has a temp of about negative 48 degrees Celsius. So this is our last video. Yay. Hopefully you made it and you did okay. I have faith in you. I think you will do great. So keep your notes out, show them to me, use them for your practice, all that fun stuff. If you have questions, as always, ask, and I will see you in class.